Hello everyone. In this lecture, let us discuss all about matrices and determinants based on HSTR and KREIS syllabus. Before starting the lecture, let me just remind you to subscribe to my channel and hit the bell icon. If you hit the bell icon, then you will get the notifications. Whenever I upload a new lecture, you will get to know that I have uploaded a new lecture and you can watch it on time. Also, if you like my work, please do share my lectures with your friends and other aspirants. And of course, if you like this lecture, please do like and share this lecture as well. Now, this is the syllabus of HSTR. Just they have given definitions and type of matrices and determinants. Okay, so without wasting time, let's start. First, let us know what is a matrix. Actually, matrices is a plural form of a matrix. Okay, now what is a matrix? It is a group of numbers, or you can say that it is an array of numbers, but that array is arranged in a rectangular manner. Okay, it is a rectangular array of numbers or functions, and they are arranged in a fixed number of rows. Rows means the horizontal lines, and a fixed number of columns. Columns means the vertical lines. Okay, this group together is known as a matrix. Now this number of rows, you can denote them by m, and number of columns, if you denote it by n, then there is something known as order of a matrix. You write it as m cross n, means number of rows into number of columns for that particular matrix. Okay, and this group or this rectangular array, it is enclosed in square brackets or simple brackets. Okay, for example, this is a matrix. Here you can see that this -5, -1 and 4, this is a column. Okay, this matrix consists of two columns, and this -5, 2, it is in first row, -1 and 3, it is in second row, 4 and -4, it is in third row. Now I think you get an idea of what are columns and rows. Okay, so number of rows into number of columns, this will give you the order of the matrix. Now when I first started doing matrices, I think probably in our PUC first year, right? We didn't do matrices in our high school. Nowadays children, they are doing matrices in their high school itself. In their 9th and 10th, they are doing matrices. But we did first time in PUC first year. At that time I wondered, what is the use of this matrices? Now I know it very clearly that matrices are very, very useful. They have lot of applications. For example, they are used in many places in engineering, in physics, to solve complicated equations. Even economics people use it. In computer graphics also matrices are used. And of course statistics, though it is like fully dependent on matrices. Okay, not only statistics, in many other branches of mathematics also matrices are widely used. Now we are talking about the order of the matrix, the m cross n, right? I'll give you few more examples. I'll give you few more examples to make you all understand this number of rows and number of columns in a matrix. See here, for example, this is also one rectangular array of numbers. Here this -2 and 5, this is the first column. In next column 5 and 2 is written. Again in third column 6 and 7 is written. Now if we talk about rows, the horizontal lines, -2, 5, 6, it belongs to the first row of this matrix A. Then 5, 2, 7, it belongs to the second row of this matrix A. Now if we are talking about the order, or you also call it as dimension, order is m cross n, right? That m is number of rows and n is number of columns. Here you know that there are 2 rows in this matrix A and there are 3 columns in this matrix A. So you can write dimension as 2 into 3 or 2 cross 3. So you say that this is a 2 cross 3 matrix. Okay, another example. Here you can see that there are 4 columns and 3 rows. So if you have 4 columns, you write 4 in place of columns. And you have 3 columns, you write 3 in place of rows. First you write rows, then you write columns. Rows into columns. So here number of rows are 3 and number of columns are 4. So you have 3 cross 4 matrix. Okay. Now these two are a rectangular matrices, isn't it? You can see that the numbers are written in a rectangular manner. That means number of columns and number of rows are not equal. In first case there are 3 columns and 2 rows are there, and in second case there are 4 columns and 3 rows are there. So number of rows and number of columns are not equal. There is another type of matrix where you will find number of rows and number of columns to be equal. That type of a matrix is known as a square matrix. It is a special kind of matrix where you can see that you have as many rows as columns in that matrix. Okay. So you should know that matrix can be a square matrix as well as a rectangular matrix. Now, as I told you, when I started doing matrices in my PUC first year, I also wondered whatever the numbers are written in the matrices, from where those numbers came, I used to wonder. I thought that this is a big secret, from where does these numbers come? How does people write any number there? It's not like that actually. Now it is very clear. Now we feel that it was very funny about me to think like that actually. Because matrices, they are nothing but simultaneous equations. We did simultaneous equations right in our high school, right? But at that time we didn't know that those simultaneous equations can be used to make a matrix. We didn't know at that time. Indirectly we were doing matrices only. Okay, so matrices, they are naturally occurring in these simultaneous equations. For example, if I have an equation 2x plus 3y is equal to 7 and there is another equation 3x plus 4y is equal to 10. This together becomes simultaneous equation, right? Excluding this x and y, whatever the coefficients are there, the coefficients of x and y, those numbers you can write it as matrices. You don't know what are x and y, right? They are unknowns here. In this case, where you have only unknowns in the equations, the coefficients only play the main role, right? You can use these coefficients and solve the equations. So you can use these simultaneous equations as matrices and you can solve them easily. Okay. Now, actually see, if you have two group of simultaneous equation, say you have one group of simultaneous equation, you have written it as one matrix, and another group of simultaneous equation is there, you have written it as another matrix, you say. So you have two matrices, for example. You can do arithmetic operations in between those two matrices. For example, you can add those matrices, you can subtract them, you can multiply with each other, you can even divide them. But in this lecture, we are going to learn about how to add matrices, how to subtract matrices, and how to multiply matrices. And according to me, it is more than enough for you all to face this HSTR and KREIS exam based on your pattern and our previous year question papers which I have analyzed. I think whatever I am discussing in this session is more than enough for you all. So you can blindly just follow this lecture and you can learn matrices. Also, I would like to request you all to take a pen and a copy and work out the numericals right now when you are watching my lecture. Along with me, you work out the numericals. In that, you have two benefits. One is that you will save time. The other is that you will be perfect in this chapter and you don't need to come back again. Okay, this is a very easy chapter. And I know that many of you will also be knowing much about this chapter. Many of you may also be knowing how to solve numericals. Maybe you all will feel easy also, but I also strongly feel that sometimes we forget some basics. So we need to recall all those basics and our hand needs to be fluent while doing this type of sums, especially in matrices and determinants, because there are many chances that we make silly mistakes leading to a wrong answer, and unfortunately if we have that wrong answer in that options, then we lose that mark. So though we know how to solve that numericals, we are getting wrong answer. So we don't want that to happen. That's why it's better we practice. Practice, of course it makes men and women perfect. So it's better you take pen and a copy and you work out with me. Okay, please pause the video right now. Bring the pen and a copy if you don't have. Okay, just don't watch it like that. Because see, not only matrices, I recommend all maths chapters in future also. Whatever lectures I upload, all maths chapters, don't watch like a movie or a serial, because see, it is maths, friends. Maths is all about writing. Okay, you need to practice them. Okay, moving on. I was telling that matrices can be added, subtracted, multiplied and divided with each other. Let us start with addition. See, adding matrices is very simple. What you do is you take the one number of that matrix. For example, you have 2 3 3 4 in this matrix, right? You take 2 here, and the other matrix also in the same place, whatever number is there, you take that number and you add. That's all. So in your resultant matrix you will have the answer of the addition of two numbers. If you have negative sign in the next matrix, then you take that negative sign, there it becomes a subtraction. Okay, I think just talking will not help you. Let us solve the numericals, then only it will help you. Okay, so first example. See, all these examples also I have gathered by analyzing all your question papers. Okay, these are all, any of the question may be directly asked. You never know, with the same number also they may ask. So each and every example which I am mentioning here, all the questions, they are expected questions. Okay, they are all very important questions. So here in this numerical, the question is, they have given one matrix. The matrix is containing a variable and a number, and they've equated it with another matrix. They are asking you to find the values of x and y. See here what you do. Here x plus 3 is there, right? In the first column and first row, in the corner you have x plus 3 in the first matrix. You can treat it with the same place digit. In that position you have 5 in the other matrix in the right hand side, right? So you can treat it with that 5. You can write x plus 3 is equal to 5. What you have to do is just compare these two matrices. If you compare, you will know that x plus 3 is equal to 5, and therefore x will be equal to 5 minus 3 or 2. So you got value of x now, isn't it? You have to find the value of y also. You can compare any other term. You have two more terms. You have y minus 4 and you have x plus y. It is your choice. Either you compare y minus 4 with 3, or you compare x plus y with 9. But if you compare x plus y with 9, you will have to do two steps again. You will have to substitute the value of x which we found here. You will have to substitute 2 there and then find y. Or you directly find it by comparing y minus 4 is equal to 3. So your minus 4 will go in the right hand side and y will be equal to 7. That is 3 plus 4 is equal to 7. So here option A will be the right answer. See how easy it is. Just we compared and we find the answer. We found the value for x and y. Okay, moving on. This is also a similar type of sum, but here I have put one negative sign with one number. You have to find x and y. You have two matrices. One matrix is in the left hand side, the other one is in the right hand side, and they both are equal. So you can treat them. You can compare those two matrices. For example, I have taken 3x is equal to 6. I can also take x plus 2y is equal to minus 4, but then again for that I will have to find value of y. So make things easier as much as possible. If you make things easier, your answer also will be correct and your time will also be saved. It will not become much hectic. Okay, so here I have taken 3x is equal to 6. My motto is just to find x. Anyhow, it is my choice. I will find it in any manner. Okay, so 3x will be equal to 6, so x will be equal to 2. And then next is I have to find y. Minus y is equal to 3, but y is equal to minus 3 because minus is there with y, right? That minus will go in the right hand side. That's why here option B will be the right answer. Okay, moving on. Same type of sum this is also, but one thing is that there we found only x and y, right? Here we have to find x and y and then we have to operate them together. Here they are asking x minus y. That means after finding x and y, we have to subtract x and y with each other. Just you can see, pause it here, pause the video here and then try to calculate by yourself. Then play the video and then match your answers with my answer. Okay. Here what I am doing is, I am taking the simple one, 3y is equal to minus 3. And so y will become minus 1 because minus 3 and 3 will get cancelled, leaving minus 1. Then I will treat 4x is equal to 8 and I will get x is equal to 2 because 8 upon 4 is 2. Now what I do, I will have to subtract, right? I will have to subtract x minus y. So it will be 2 minus of minus 1. So x minus y will be equal to 3. See friends, here signs are very, very, very important. If you don't write minus there with that 1, then your answer will become 1 and that 1 is there in option. That will be 100% wrong answer. So you have to practice such that you never miss signs. What happens actually in exams, no? Because of stress and because of anxiety, no? We do it in hurry, we miss some signs. It is very silly mistake. That will lead to a wrong answer. Okay, so you have to be very careful. Here option C will be the right answer. Okay, moving on. I am giving you one question, similar type of question. Here just you have to find value of x. No need to find value of y, but you have to find value of x. This is assignment for you. Here I'll give you one simple clue. To find x minus 2y, you will have to find y first. Then only you can find x minus 2y. After you find x minus 2y, then only you can find value of x. Okay, this is one clue for you. Please do work out this sum and write the correct answer in the comment section. Okay. Now this is another example. I am going just stage by step, just one step ahead I am going. Okay. Here the question is one matrix B is given and then another matrix is given which is A minus 2B. Using these two matrices, they are asking us to find matrix A. See, right hand side you forget, just for instance. Just to see left hand side, it is B and A minus 2B. How can you find A with these two things given as data? You can first multiply 2 with B. Then you can subtract A minus 2B with B. Then you can get answer A. Isn't it? That is what they want us. So you can just plan in this manner in your mind and then you can proceed. Now we can do the same thing with the matrix. So this is the matrix. A minus 2B is given. Now I can put this minus 2B in the right hand side, right? If I put minus 2B in the right hand side, I will get A is equal to the matrix plus 2B. Or I know what is the value of matrix B. That I will write it here. And then I will multiply 2 with that matrix. Multiplying that single number is very easy. Just multiply it with the numbers given inside the matrix. 2 into minus 1 will become minus 2. 2 into 5 will become 10. 2 into 0 will become 0. And 2 into 3 will become 6. Okay. Here it should be 6 actually. Now you can just add these two matrices. If you add, you will get the answer. That is what you wanted, right? So you can pause the video here and then you can calculate it by yourself. Just see if you are getting the same answer as I am getting. Okay. So here option D will be the right answer. Okay, next question. Similar type of question. Here one thing is that there you had only single B in one matrix. Here you have two equations. In left hand side you have A plus B for one matrix and A minus 2B for another matrix. You have to find A only here also. What you do here? First you multiply 2 with the A plus B. Now you add 2A plus 2B with the A minus 2B. You get 3A, isn't it? Now same thing you can apply using these matrices. First, to get 2A plus 2B, you take 2 common and you write A plus B in the bracket. That A plus B matrix is given, right? Now you substitute that 1 0 1 1 and then you multiply it with 2. You will get 2A plus 2B. Then what you do? A minus 2B is already given, right? You write this equation 1 for 2A plus 2B and write equation 2 for A minus 2B. You take these two matrices. Then you add. In the left hand side you will have 3A because 2B will get cancelled with minus 2B. Right hand side you write the matrices as it is. Now you just add them. But the one thing is that you have to keep that minus in your mind. Okay. You have minus 1 in the second matrix. So keep that in the mind and you find the answer 3A. Once you get the value for 3A, now you have to send that 3 in the right hand side. Means A will be equal to 1 upon 3 into that matrix. You see if that is there in the option. Yes, it is there. That will be your right answer. Okay, so this was all about addition and subtraction of matrices. Also, we sort of had an idea of division of a matrix with a single number. Here we did it right. So 3A was equal to one matrix. We send 3 in the right hand side. That is how you do. Still, if you want to take that 3 inside, you can do it. You can write it as 1 by 3, 1 by 3, 2 by 3 and 1 by 3 in that matrix. Okay, if that was there in the option, then you could have ticked that also. They did not proceed it with the next step, so you have ticked it here only. Okay, now let us know how to multiply two matrices. We learned how to multiply a matrix with single number, how to divide a matrix with single number. Now I am talking about multiplying two matrices with each other. How we do it? See here, for example, I have two matrices A, B, C, D. The other one is E, F, G, H. How you do it? You first multiply AE, then you add it with BG. That is your first place. And again in the second place, AF plus BH. Then again you come into the second row, first column, CE plus DG. Again the second column and second row, the corner number, you first multiply C with F, CF plus DH. Okay, just you pause the video here and you write it by yourself and see. Here, because it is an online class, I cannot make you all understand how to exactly do it. That's why I am just giving you with the alphabets so that you can relate with it. Okay, this is simple thing. This is how you multiply two matrices with each other. I'll give you an example. For example, if you have two matrices like this, here what you do, just the way you did there, AE plus BG. What is there in place of A here? -2 is there. What is there in place of E here? 6 is there. You multiply -2 and 6. -2 into 6 plus, what is there in place of B there? 1. Again, what is there in place of G? It is -7. Multiply 1 into -7. Add these two things. Okay, in the same lines as you did here for ABCD and EFGH, these two matrices, same thing you have to do for these numbers. I am giving you example to relate. If you write it down, then only you can understand. What you are doing here is you are taking a number from first column and first row, and then you are multiplying with the first column and first row of the second matrix. Then again you are also multiplying this one with -7, and then you are adding that -2 into 6 plus 1 into -7. Okay, so this is how you multiply matrices. So simple thing is what you are doing here is to multiply matrices. You are just playing with the columns and rows, the numbers in the columns and rows, and then you are multiplying. When you multiply those two numbers, you are adding those two numbers. Okay, so this is how you are doing. You just write it and see, it will be easy for you. I'll give you another example so that you can easily understand. Here the question is that there is a matrix 1 0 0 1. You have to find A square. That means you have to multiply A with A only. So you use that same thing. A into A, you write these two matrices and then you do it. 1 into 1 will be 1 plus 0 into 0 will be 0. Again in the second column it will be 0 into 1. It will be 0 plus again 1 into 0. It will be 0. So your answer will be 1 0 0 1. This matrix, if you have multiplied this matrix with the same matrix, then you are getting the same matrix. So here option C will be the right answer. Now taking this same example, I will give you another example. You have to find A square into A square. Means first you find A square, then again you multiply that A square with the A square, means same two matrices. You will get same answer 1 0 0 1 only. So this matrix is also known as a identity matrix or unitary matrix. It is a special type of matrix containing 1 0 and 0 1. The speciality of this matrix is that no matter how many times you multiply the same matrix, you will get the same answer. You will get the same matrix in the answer also. Okay, this type of a question they asked in your HSTR exam in 2015. So option 4 is the right option. Now this was all about addition, subtraction and multiplication of matrices. Now let us note what are types of matrices. There are few types of matrices. What are they? They are row matrix, column matrix, zero matrix, diagonal matrix, scalar matrix and unitary matrix. Unit matrix means the same identity matrix we did there, right? It was a 2 into 2 matrix, 1 0 0 1. Here it is a 3 into 3 matrix. Row matrix means you have only row in that matrix, you don't have any column. In the same manner, for column matrix you don't have any row, you have only column in that matrix. And in zero matrix or null matrix, there are no elements with the other than 0, only zeros will be there in that null matrix. And in diagonal matrix, if you draw a square like this and if you draw one diagonal, only in the place of that diagonal you will have numbers or variables, except that in all other places you will have 0. Scalar matrix, it is same like diagonal matrix, but here only difference is that in the diagonal, whatever is written, they all are same. Here you can see in diagonal matrix you had ABC, in scalar matrix you have AAA. Okay. One more matrix known as transpose of a matrix. See, if you have a matrix, say for example you have capital A, that is one matrix. The components in that matrix are A11, A12, A21 and A22. If you have to write the transpose of it, what you do know, you write A21 in place of A12, means you make columns into rows and rows into columns. That is only your transpose matrix. For example, If you have 3 4 and 2 1, if you are asked to write the transpose, then you write it as 3 2 4 1, means 2 you sent in the place of 4, 4 you sent in the place of 2. Okay, now let's have just a summary based on what are types of matrix. For example, if you have question like what is meant by a null matrix, see, they will not ask you questions, but then they will ask you as a fill up or as a multiple choice, right? So you can ask yourself this question and you can answer it yourself. What is a null matrix? A matrix whose all elements are 0. Then what is a transpose of a matrix? In transpose of a matrix, the matrix obtained by interchanging its rows into columns and columns into rows. It is known as transpose of a matrix. What is meant by a diagonal matrix? A diagonal matrix is a matrix in which the entries outside the main diagonal, they are all zeros. What is meant by square matrix? If the number of rows and columns in a matrix are equal, then it is called a square matrix. Okay, I hope you all got it now. Now let's have an example based on transpose of a matrix. The transpose of a square matrix is, means if you have a square matrix and if you write a transpose for it, for example, if you have 3 4 2 1, then what you write it as 3 2 4 1. So the resultant will be a square matrix only. There will be no change. If you have a square matrix, its transpose also will be a square matrix. Or if you have a question like this, the transpose of a column matrix is, means if you have a column matrix, then if you are going to write the transpose of it, then you will have a row matrix. You have to be careful. You should imagine, you have to write and understand what the question says. Okay, now this was all about matrices. Now let's talk about what are called determinants. So determinants, it is nothing but a scalar value. Any matrix, you cannot calculate it within the matrix, right? If you have two matrices, then you can calculate anything relating to each other of those two matrices, but within the matrix you cannot do anything. If you want to find the value of one particular matrix, then you can write that matrix as a determinant, means just two lines, parallel lines. You will not write a square bracket here in determinant, just two parallel lines. Then you write the same elements. Now you can solve this determinant. It is easy to solve a determinant. It will give you value of a matrix. For example, if you have matrix A is ABCD, you can write it as a determinant and you can solve it. How you solve it? You do just to do cross multiplication. AD minus BC. You multiply A with D, subtract with the BC. Okay, that is your determinant A. If you have a bigger determinant wherein you have a 3 columns and 3 rows, then what you do? You can make it as a short determinant. See here how you do is, you write A1, you take A1 outside and then you write B2, B3, C2, C3, you make it as a small determinant. Then write minus, again take A2 as a common, write B1, B2, C1, C3 as a small determinant. Same thing you do for A3. One thing you have to remember is that first you are subtracting, means A1 with the determinant, the small determinant, minus is there. Then A2 with that small determinant, again plus is there. Then A3 with that small determinant. Okay, now it is easy, right? Now you can, within the determinant, you can just cross multiply. While cross multiplying, you will have minus inside. Okay, just pause the video and practice it here itself. It is very, very useful and it is very easy. Only thing is that you should catch the rhythm of how to calculate these determinants. Okay, I'll give an example. Here, see, I'm not giving you big examples, just simple examples. In HSTR and KREIS, they are not going to ask you very big examples. Simple examples they will ask you, but then if you know the procedure, then only you can answer those questions. Okay, the question is find the value of x if there are two determinants. What you do, in the left hand side you solve the determinant, in the right hand side you solve the determinant, you equate because they both are, in the question only it is given that they both are equal. With this you can find x, right? It is simple. You have a quadratic equation, you find the value of x. That's it. Okay, one thing you have to remember is that if the square goes in the right hand side, then you will have to write plus or minus. In the options, if there is only plus or if only minus is there, then you don't take that answer. You take the answer where you have plus or minus. Okay, next example, same type of example. Here I am giving you options. Same thing you have to do. You just equate those two determinants, you solve them and then you find the answer. In that answer you will have plus or minus. Okay, here we are getting x square is equal to 36, so x will be equal to plus or minus root of 36 or plus or minus 6. So option C will be the right answer. Now we have one simple application of this determinants. Using these determinants, you can find the area of the triangle if three vertices of the triangle are given. This is the formula for that. It is your wish. Either you remember the first formula, second formula. I feel comfortable with remembering the second formula because it is very easy. That formula came from the first formula only. Half into that determinant with x1, y1, 1, x2, y2, 1, x3, y3, 1. Okay, that solution for that determinant is only in the next step, but that is the formula which you can remember easily. Okay, where x1, y1, x2, y2, x3, y3, they are the vertices of the triangle. For example, if you have a question like this, you have three vertices of the triangle, you just denote them with x1, y1, x2, y2 and x3, y3. Then you use this formula. It is your wish. Either you use, it is better you don't use this formula. You directly, you know the values, you just write the formula, the other one. How do you solve this determinant? No, that formula. Or it is your wish. Let us start with beginning again. Say this is the formula for triangle ABC. You substitute the values x1, y1, x2, y2 and x3, y3. You know what are the values are given in the question. Now you solve it. Okay, it is your wish. In two ways, whatever you are comfortable, you can do like that. Here in this case, your answer will be 20 square units. Okay. I'll go for another question. Similar type of question with other numbers. Same thing you have to do. Just to substitute the values. Then you calculate the determinant and then you multiply it with half. Okay. Here just I think you pause the video. Okay. I'll disappear this answer. Wait. Now you pause the video and you try to do it by yourself. Then you match it with the answer. Okay. Okay. This one is an assignment for you all. Same three vertices of a triangle are given. You have to use that half into that determinant. You substitute all the values, but you will have y3 will be equal to k. Okay. And in the right hand side, you will have 9. Half into that determinant will be equal to 9. Using this, you have to find the value of k. Okay. Please do let me know your answers in the comment section. I'll be waiting for your answers. Okay. So I hope that I helped you all with this video. See, I am not giving you spoon feeding. I don't want to give you spoon feeding because if I do each and every step, you will never understand what I am trying to tell. Okay. If you do it by yourself, then only you will understand. Okay, friends. This was all about matrices and determinants. If you have any queries, please do let me know in the comment section. And I don't feel you will have any queries. So this was the best lecture for matrices and determinants. I feel more than this is not needed also. Okay, so please do like, share and subscribe to my channel and please keep working hard. Okay, thank you. All the best. Bye.